Okay, today we'll be doing 1015 representing functions as a power series. And if you haven't learned 1014, which teaches you how to do Taylor and Maclaurin series, this video won't be much help because none of it will make sense to you, since the formula for finding both of those series is what you will need to represent a function as a different power series. So here's an example of the two formulas for a Taylor and Maclaurin series. For Taylor, it's the summation of the function. It's f to the n derivative of c, which is the center of the equation, of x minus c to the n over n factorial. And as you write it out, it's f of c plus the derivative of f of x of c of x minus c on. And then for Maclaurin series, it's centered about x equals 0. So you can just ignore the c and it's just x to the n, and it's the same thing. Okay, so the example for one of these questions is write the first four non-zero terms and general term for series that represents the function h of x equals cosine of 2x. And the formula, well, the Maclaurin series for cosine of x is is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6 over 6 factorial, and so on and so on. Eventually giving you the power series as being, it's an alternating series because cosine is alternating, and it is even, so it's just 2n. And so, for example, that's what cosine of x will equal. And it's helpful for solving this one because it's just cosine of 2x. So every time you take the derivative of cosine of 2x, because the first term is just f of x and the second term is the derivative of f of x, and then so on and so on. So it'll basically be 2 cosine 2x and 4 cosine 2x, 8 cosine 2x. And a little faster way to do this is just take the 2 and raise it to the power of the x, but it's not super helpful. So it'll be pretty similar to the original one, just with the increasing derivative of the 2x adding on. So it'll be 1 minus 40x squared over 2 factorial plus 16x to the 4th over 4 factorial minus 64x to the 6 over 6 factorial, which you can simplify, but it's not that important. And you can write the summation for this as being, since it's still alternating, and it is x to the 2n over 2n factorial. It's pretty much the same, except for you have to multiply by 4 to the n, or 4 to the number of terms. So then in the first term, 0, then 4, 16, 64. And then a further example of that is you can write the first 3 non-zero terms for cosine of 2x minus 1 over x squared. So the cosine of 2x is the same. The minus 1 is not really that important because it doesn't affect it that much. So the simplified version of the series above is negative 2x squared plus 2/3 x to the 4th minus 4x to the 6 over 45, which is the simplified version of the series above. And all all that you're adding into this is the x squared, which you'll be dividing by, because it's being divided by in the function. And so that's another example of expanding on. Once you're able to find one series, then you can manipulate it by just different parts of a series. And then another one would be find the Maclaurin series for the function e to the 3x. And so the simple series for e to the x as a power series is 1 plus x squared over 2 plus x cubed over 3 factorial, because every time x equals 0, since it's a Maclaurin series, so it'll be e to the 0, which is 1. So that's why every time you take the derivative, and every time you take the e to the x, it's just e to the x. However, when it's e to the 3x, it'll be e to the 3x, then it'll be 3e to the 3x, then 9e to the 3x, and so on and so forth. So you're pretty much having to multiply by 3 each time, except for the first one. So it'll be 1 plus 3x plus 9x squared over 2 plus 27x cubed over 3 factorial, which, if you want to write it in the full power series notation, it'll be represented as that, simply because you're multiplying by 3 every time, or yeah. And last example will be x cosine x squared. And this one is pretty similar to the ones we've done before with cosine, as well. Right here is what cosine is, and the only thing you're changing is the fact that it's being squared. So you'll take this whole series here and you'll have to square it, which is 1 minus x to the 4th over 2 factorial plus x to the 8th over 4 factorial minus x to the 6th over 6 factorial. That's a 12. It's supposed to be a 12. Because you're just multiplying by 2 since you're squaring the cosine term. And then you also have to multiply this by x. So it'll be x minus x to the 5th over 2 factorial plus x to the 9th over 4 factorial minus x to the 13th over 6 factorial. And then the last step is to write the power series for it, which can be written as -1 to the n, since cosine's alternating series, x over 2n factorial, because the 2n factorial will be these terms, and then in normal cosine it's just x to the 2n. However, this one's being squared, or being multiplied by 2 again, so it'll be 4n, and you have to include that extra x, so it'll be plus 1. And that's how you solve for functions as power series.